Okay, so we're going to do a video here on how to find the volume of a prism and a cylinder. So a prism is something that has two congruent bases, and those bases are connected by segments. So like it could have two rectangles as its base, or I could make a prism where I have, let's fix that. Two triangles as its base, right? So any way that we do this, the first thing I want to talk about is what's called its lateral area. Okay, so the lateral area is the area of the side, this side, the back, and the front. Okay, so it's not including the top and not including the bottom. Okay, so how do I find the lateral area? If you think about this, if you were to cut this apart, right, this all the way around here would be the perimeter of the base. Okay, so let's try to envision this thing cut apart here. So let's get rid of the triangular one. Okay, and envision what the rectangular one would look like cut apart. All right, so this would look like that's the back, the side, the other side, the front, the top, and the bottom, right? So the lateral area is this plus this plus this plus this, right? So this distance here is the same as this, right? So that's the perimeter of the base. This distance is the same as this, which is the height of the prism. So that's a rectangle, right? It's P times H. So the lateral area of this thing is going to be its perimeter times its height. Now, if I want the total area to cover the whole thing, right, then I would add the top and add the bottom. So that would be twice plus twice the bases. So that's, oops, let's make sure that this is clear. The lateral area is the perimeter times the height. The total area is going to be that lateral area plus twice the area of the bases. Now, how about the volume, right? So let's get a new drawing here. So let's this time work with one that has like a triangular base. So there's my triangular base. There's the congruent base up top, connected by line segments coming down. Okay, so the volume of this thing is the number of cubes it takes to fill it, right? So the way that I tend to think about this is like, imagine there was a tray of cubes, just one tray on the bottom, 1 cube high. Well, how many cubes would it take to fill that? Well, the number of cubes there would be equal to the area of the base, right? So that's 1 tray of cubes. If I want the volume, the question is like, how many of those trays of cubes would it take to fill the whole prism, right? So the 1 tray of cubes has a volume of the area of the base. How many cubes is equal to the height, because each of these is 1 cube tall. So it's like 1, 2, 3, whatever the height of the prism is. So the volume of any prism is the area of its base times its height. Okay, so that gets me the basic idea here. Now, when I move this to cylinders, I can be a little bit more specific. A cylinder is basically a circle, right? Let's make a circle on the top. Comes down, puts a circle on the bottom. Right? And then we got this, right? The two important dimensions of the cylinder is the radius and its height. Okay, so if you think about the cylinder, if I cut it apart, I get like the soup can label, and then I get a top and a bottom. Okay, this here is this. So that's the circumference of the circle. That's 2 pi r. This is this, so that's still the height. So the lateral area, the area on the side, or the area that would like be taken up by the label, is 2 pi r times h. Well, that's pretty convenient, right? So what am I adding on to this to get the total area, right? So the total area is now the lateral area plus the base area, but the bases here are circles with radius r, so this is just going to be 2 pi r squared. Okay, so that gets me a formula for the total area of a cylinder. Well, we knew from all a cylinder really is it's just a prism with a circle as its base. So remember, the volume for the prism was base area times height. I can be a little more specific here because I have a formula for the base area. The basis here is a circle. The circle has a radius r, so that base area is pi r squared times the height. So there we go. We have lateral and total area formulas for prisms, lateral and total areas formulas for cylinders, and volume formulas for each. Sometimes the total area, I think in the notes I called it the surface area, but it's interchangeable. Total area, surface area, they're kind of the same thing. So there you go. Volumes of prisms and cylinders.